Hello students, so in this problem sin theta is given as n times sin theta plus 2 alpha and we have to show that tan theta plus alpha is equal to 1 plus n whole upon 1 minus n into tan alpha. Now we have to show the result for tan, whereas the given trigonometric angle or given trigonometric function is sin theta. The trigonometric angle given is theta plus 2 alpha, whereas the required answer should have angle as theta plus alpha. Now the question is how to solve this. So many of the students, they start with the tan theta plus alpha and then try to find out the value of tan theta, then tan alpha, and then they substitute to get the value. But here we'll use the another approach, because by that way we can get answer in minimum number of steps. So what is that approach? So here from the given result I can find out the value of n. How? By shifting this sign on the other side. So here we can say that sin theta upon sin of theta plus 2 alpha is equal to n. So here we got the value of n. Now using this value of n, we'll find out the value of 1 plus n upon 1 minus n, and by solving it we can get this result. So let's start. So here I'll say therefore 1 plus n upon 1 minus n is equal to. So to get 1 plus n, I'll write 1 plus the value of n, that is sin theta upon sin of theta plus 2 alpha whole upon 1 minus sin theta upon sin of theta plus 2 alpha. Now let's solve this. So first of all we'll take LCM. So here we will get 1 into this sin term will be sin theta plus 2 alpha plus sin theta. In the denominator we will get sin of theta plus 2 alpha. Similarly in the denominator we will get by cross multiplication sin of theta plus 2 alpha minus sin of theta whole upon sin of theta plus 2 alpha. Now we can cancel denominator of both the terms because it is same, and now for the remaining terms, if you'll observe carefully, then we can apply the factorization formula, because here this sin of theta plus 2 alpha I can consider it as sin C and this as sin D. So I can apply the formula of sin C plus sin D in the numerator and sin C minus sin D in the denominator. So first of all let's see what is the formula of sin C plus sin D and sin C minus sin D. So here I'll say therefore sin C plus sin D is equal to 2 times sin C plus D whole upon 2 into cos of C minus D whole upon 2. Similarly sin C minus sin D has the formula as 2 times cos of C plus D upon 2 into sin of C minus D upon 2. So let's apply this formula. So I will say therefore 1 plus n upon 1 minus n equal to. So here theta plus 2 alpha is C and theta is D. So this will give us 2 times sin of theta plus 2 alpha, that is C, plus D, that is again theta, whole upon 2 into cos of theta plus 2 alpha minus theta whole upon 2. In the denominator we will get 2 times cos of theta plus 2 alpha plus theta whole upon 2 into sine of theta plus 2 alpha minus theta whole upon 2. Now we can cancel this positive theta and negative theta. Here I can cancel this 2 also, and here we will get this term is theta plus theta, that is 2 theta plus 2 alpha, and in the denominator we have 2, so we can cancel all 2's. So here we will get theta plus alpha. So sine of theta plus alpha. From here 2 and 2 will be cancelled, so we will get cos of alpha upon, again same, 2 theta plus 2 alpha. I can take 2 common, it will be cancelled with this 2, and we will get cos of theta plus alpha, and here by cancelling 2 we will get sine of alpha. Now this sine theta plus alpha upon cos theta plus alpha, we can write it down as tan of theta plus alpha, and this will become cot of alpha, because cos upon sine is cot. Now what we'll do is, we'll take this cot here in the denominator. So we know that cot of theta is 1 upon tan of theta, it is 1 by tan theta. So by this property, this will become tan of theta plus alpha upon tan of alpha, and this is the value of 1 plus n upon 1 minus n. Now we will take this tan alpha on the other side, so here we will get 1 plus n into 1 minus n into tan alpha, which is equal to tan theta plus alpha, and my friends, that is our required answer. So here we have proved the result by using the formula of factorization. Thank you.